Good day, good day. Now let's talk power supplies. So power supplies, this will be part 1. So that means that you cannot skip this, alright, then go to other videos without checking this one first. Now, on your textbooks, please do the theory that is self-explanatory from page 130 all the way to page 137. And then on 137 and 138, these are transformer calculations. I believe you've done them in grade 11 and grade 12. I'm going to start where we talk about rectification. Now, what is rectification? Alright, there we go. Rectification, which you find on page 141. Alright, it's when you convert AC into DC. Okay, so that is a conversion of AC to DC, meaning you will have a waveform like this. This is a sine wave, and then you convert it into what? Into DC, where you've got loops like this. Alright, this, it was your AC from Eskom, then it gets converted into DC. Typical examples, you all are using a rectifier on daily basis. Your cell phone charger. Okay, your cell phone charger, basically it receives, you connect it onto your twin plug. Alright, you connect it to your twin plug there. Alright, after connecting to your twin plug, it will go through the charger, and then the charger, it will be receiving AC in sine wave. The output, it will be a DC. Alright, but that DC will be filtered. We'll talk about filtering later on. Okay, so this is AC from Eskom, this is DC. Now that has been rectified. Now, typical circuit. Okay, we've got half wave, full wave, half wave, and full wave. Half wave, basically, we've got, this is Eskom power, that circle. Okay, let me remove that. Then you've got a transformer on the left. Alright, this is the primary side. Then you've got on the secondary side, this is what we are having. Then you've got your diode there, and you've got this. There we go, RL. Okay, so this is your diode D1, and this is your transformer T1. Okay, so what's happening here? In this case, Eskom power will be coming in, right, as sine wave. Right, it will go through the transformer, and this transformer basically it's a step down. Alright, step down, that means that probably on the side it was 230 volts, on the side it will come out as 12 volts. Step down, that means that it decreases the amount of voltage. Now, as it gets decreased, then it goes through through only one diode. As a result, let me redraw again. This is Eskom power. Okay, sorry for this uneven. Okay, let me just redraw again. Cool. This will be Eskom power. I tried to draw the sine wave, but however, because of its half wave, you will only have these. There we go. So what happened to these gaps? What happened to this gap? This gap. Okay, that means that during these gaps that you are seeing, the diode was off. The diode was off. Okay, and now, alright, and on these points here where I draw these dots, the diode was on. So we are saying it's a half wave rectifier because the diode was only working for half of the time. It was on here, off here. It is on here, off here. As a result, this is the result at the bottom, where we have what? A rectified waveform. This is this one at the bottom. It's the rectified waveform. Okay, the one here at the bottom is a rectified waveform. Okay, however, this is what we call a half wave rectify. Okay, that means that we only have positive half waves. All right, and then we go to the next one where we talk about full wave rectification. Full wave rectification, we've got two. Full wave rectification. We've got two. Those two, basically, you've got center tap and what else do we have? We've got bridge rectify. We've got bridge rectifier there. Bridge rectify. Now center tap, it uses only two diodes. This one uses 4 diodes. In both situations, okay, in both of these, your waveform will come like this, a sine wave. Because of its full wave, then you will have something like that. Okay, so meaning that you've got the both of these. The diode will be on the positive, negative, positive, negative, positive, negative, positive, negative. That's why here at the bottom, all of the positives and negatives are represented compared to the one at the top. Here at the top here, all right, only positives are represented. The one at the bottom here, all right, positive, negative, positive, negative, positive, negative. So this is a full wave rectifier because all the entire waveform gets to be rectified. Remember, what is rectification? It's when you convert AC to DC. So when you check here, let me come back here. This is AC, and at the bottom here, this is DC. Same thing here. All right, we've got what? AC here, and we've got DC at the bottom. Cool. Now let's start with the center tap. Center tap, how many diodes does it use? 2. So let's draw. And remember, there are two ways of drawing a. You can draw that one where you are, where it's shaded like this, but there must be the core. This is to indicate that you are having a transform. But remember, you must fully shade this. Okay, and then you've got center tap. Okay, now you will have, okay, let me just, something is, okay, here you've got a diode and another diode here. Then you connect at the top, and then on the side you've got RL. RL is the final user of the current here. So it gets connected here all the way there. Aha! So here you've got what? You've got D1 and you've got D2. There we go. D1 and D2. Let me see. Center tap, you will find it on page 144 of our textbook. Alright, half wave, you will find it on page 141. So in this case, on our textbook, you will find it on, okay, let me write the site, page 144. Cool. So how does this one work? Let me draw again. Eskom power. Alright, this is your sine wave coming in as 230 volts. Alright, then this one, you will have. So that means that this one, it was D1. Okay. This was D1. Alright. And this one, D2, D1, D2. Meaning that they keep on switching spaces. When during the positive half cycle, this is on. During negative half cycle, this one becomes on. So that is, they keep on switching. Alright. When D1 is on, D2 is off. When D2 becomes on, D1 becomes off. So as a result, this becomes what? FW. Okay. Full wave rectifier. Okay. So that's our RL in this case. And then we've got the last one. This one, I'll have to go to Google to find the bridge because it's a bit complicated to draw for me, but for you, you have no choice but to draw the proper thing. Let's just checking here. Bridge rectifier. Okay, there we go. Yeah, I'm just looking for the circuit. Okay, now I was looking for a circuit. Let me come here, double click here. Okay. Okay. There we go. This becomes our circuit. Okay. Now, if you can check with this one, what do we have? We've got Eskom power. Okay. And the bridge rectifier is the only one that can be used without a transformer. Let me get you the one that has a transformer. That has a transformer. There we go. Just okay, I'm just getting you this. There we go. There's another one. You've got the power supply. Both of them, they are correct. The other circuit has what? It has a transformer. Okay, it has a transformer, and the other one, it doesn't have a transformer, which is still correct because why? We rather with bridge rectifier can be used with or without a with or without a center tap, without the transformer. Cool. So in this case, all right, only two are working at a time. Let me repeat, only two diodes are working at the time. So let me show you here. For both of them, you will have the top one as compound. This is as compound. This is after rectification, where you've got D1 and D2. Here it's D3 and D4. So D1 and D2, Maybe I should have written it inside. But this is 1 and 2. This is 3 and 4. 1 plus 2, then 3 and 4. So this is how basically they work. Okay. I don't know why they have 0 here, but it doesn't matter at all. Okay. So they work in pairs, meaning that, alright, during the positive half cycle, these two will be working. During the negative cycle, these two will be working. So that's how it's working. So this is also a bridge rectifier as illustrated in this case. So in a nutshell, that's what we are having there in terms of rectification. In terms of rectification, that's what we're having. So I'm gonna be explaining calculations associated with these circuits, alright, on the next video. I wrote part 1. Alright, please check part 2. Thank you.